All right, so I'm just going to show you how to do this integral real quick. So we've got this region R bounded by, and then they give you four things. A curve, y equals 2 cotangent inverse, the x-axis, x equals 8, and x equals 11. And so if you go to Desmos to look at what that looks like, sorry, I'm coughing, but I'm not going to start over. We can type in, sorry, we can type in the arc cotangent, right? That's probably the easiest way to type it. So I'll go ABC. Oh wait, maybe it's in here. Functions. Oh, they do have it. Okay. Cotangent x here, and it's 2 cotangent. So I put a 2 in front. Okay, there it is. So this is the curve, right? Now then they want x equals 8, so I'm going to go x equals 8, that's a vertical line, x equals 11, that's a vertical line, and then they have the x-axis, which is y equals 0. So you've got these four curves, and the idea is there's just a region in here that, that the area is. So let me take the pi off here, because we don't need it. Delete. Okay, 8 and 11, left and right. Now if I go up here, I can probably make this look a little nicer. Since what we want is this area below the red curve and below and above the purple curve, I can probably do this. So let me delete this and just say 8, nope, 0 less than or equal to y less than or equal to that. So that's the area that we're talking about, but then only between x equals 8. So if I come here and I go 8 less than or equal to x less than or equal to 11. Okay, so that's the exact area that we're talking about, this area right here. So it's just below the cotangent curve between 8 and 11 is what it comes down to. So that's actually pretty simple. So just let's go back to the notes here. And so this is what we're talking about. I already forgot what the cotangent looked like. I'm gonna go look at it again. Oh, I deleted it. Okay. All right, so on the positive side, it just does that. All right, that's easy enough. So, so on the positive side, right, it just does that. And then we're just going 8, 11. There's the area. Okay, so that's pretty simple. So if you're trying to calculate it, you just need to set up an integral for it. Well, it's just going to be the integral from 8 to 11 of 2 cotangent inverse x. So that's all they're asking you to do. They just ask you to do it in a weird way. Okay, and that's the region R there. So how are you going to do that integral? Well, you've got to look at your list of common derivatives and integrals, and if you do, you should find this one, that the integral of wait, what section are we in? This is not going to be right. Hold on. Yeah, this is a little bit more complicated than I thought it was. In my head, we were doing something slightly different. Let us keep going, though. I lost the mail. Okay, there we go. So this is the integral that you need to do. I was going to say you just look up the integral, but that's not actually true. What you're going to need to do here is this integral is a little bit complicated, and so this must be from the section on integration by parts. And so what you're going to have to do actually is you need to know the derivative of cotangent inverse, right? So you need to know this, that the derivative of cotangent inverse x is -1 over 1 plus x squared. And you can get that from the list of common derivatives and integrals, or from the lecture on inverse trig functions that I did. So you need to know that. So how are we going to do this integral? So the way we do this integral is with integration by parts. So you have to pick u to be cotangent inverse, and then you have to pick dv just to be dx. So what happens is you take the derivative on this side, so you get du. It's the one that I wrote up there, negative 1 over 1 plus x squared. Then here you integrate, dv goes to v. So there you go. Antiderivative of dx is x when you do the antiderivative. So what that means is I can come here, do my integration by parts. I didn't do this with the 2 here, so maybe I will. I'll just put the 2 in there, and then I'll put the 2 there. Okay. So if you do integration by parts here, you know that the integral should be uv minus the integral v du. So uv are this one and this one, right? So we're going to have multiply those together. 2x cotangent inverse x, like that. And then minus the integral of v du, which are going to be these two. So you multiply those together, you have the integral of negative 2x over 1 plus x squared. Now you can take the negative out, and we can write it as 2x cotangent inverse x plus the integral of 2x over 1 plus x squared. Now, that means you have this integral left to do. Now that integral is a basic substitution integral. I'm going to do it off to the side. If you have the integral of 2x over 1 plus x squared dx, I should have had a dx somewhere. There we go. If you have that integral, you let u equal 1 plus x squared. Du is 2x dx. So you substitute that in, you have the integral of just du over u, which is ln absolute value of u plus a constant, or ln absolute value 1 plus x squared. And you don't even actually need the absolute value, because 1 plus x squared is always bigger than 1 because x squared is positive. So come back to my integral. I have 2x cotangent inverse x plus ln absolute value 1 plus x squared. Again, you don't really need the absolute value. Now, the thing is that this was supposed to have limits of integration, right? 8 to 11. So we still have to do those. So I should have been writing it on every line, but now that we're done, basically you have to come back and put in 8 and 11. And that should have been like on all of these, right? Like that. 8, 11, 8, 11, and so on. So you have to put in the 11 here. 2 times 11 cotangent inverse 11 plus ln, put in an 11, 1 plus 11 squared, and then minus, and then you put an 8 in, 2 times 8 cotangent inverse 8 plus ln absolute value 1 plus 8 squared. And you just have to work that out. But there's not going to be really very much you can do to simplify this. So like this first part here is going to be 22 cotangent inverse 11. Fine. Then you have natural log of, it's going to be, what is that, 1 plus 11 squared. So 11 squared is 121, so this is 122. You don't need an absolute value because 122 is positive. Minus, then you've got 16 cotangent inverse 8. And then you've got a plus, no, minus because of the minus. The natural log of, what is that? So right here, 64 plus 1, so 65. Like that. And they probably write it maybe, maybe it's a slightly different way that they write it in the answer, but something like that. So it's just doing this integral but it is an integration by parts integral, so it's not the easiest possible integral to do. So I'm just going to upload this video to YouTube and send you the link. You don't need to know that because if you're listening to this, you already have the video. All right, that's it.